Hello again. Thanks for watching this video and studying your math with us. The conclusion of this video is that the motion of the planetary orbit is if we start in cylindrical coordinates, that means in 3 dimensions. We have r being one of the components, theta being the other component, and we have z being the third component. We know from high school physics and COD Calculus 2 that F as a vector is the product of the mass times the acceleration, and this is the second time derivative of the r vector. We also know that the force as a vector is totally due to the gravitational pull, so this is going to be minus g, the constant, mass of the sun, mass of the planet, divided by r squared. That's the difference between their centers of mass, and this is going to be along the vector joining their centers of mass, or along the radial direction. What we can do then is set these two equal to each other, and we can cancel the mass of the planet, and we get that the acceleration vector r double dot is in the same direction, is a scalar multiple of the r vector. That means these two are parallel. That means that the sine of the angle between them is 0. Also, if we think about r dot, that's a scalar multiple of r dot. The scalar is 1. So if we take the derivative with respect to time of the cross product of r and r dot, we use the product rule here, and both of those vectors are 0. This one because of that conclusion, and this one's equal to 0 because of that conclusion. Now, since the derivative with respect to time is equal to the 0 vector, that means that this cross product is in fact a constant vector. So if we advance the slide and we think about what that means that r and the movement of r is always perpendicular to a constant vector. That means it is lying in a plane. More later and soon when we discuss Kepler's second law.